Hello everyone. Very good morning. Good morning Samir, Shweta, and good evening for people joining from other places. Hello Kalpana. Good morning Lars. Okay. So friends, couple of people will join late today. So maybe let them join there, and maybe the initial part of session what they have missed, I think the recording is available for them to listen. So I think it should not be a big problem. Okay. So yesterday I introduced you all to a concept called table calculations, big table calculations. So how many of you are still not that confident in using that table calculations and how that is been computed? So I assume that every one of you understood the concept of table calculation. And can someone tell me what is addressing field? So what basically the addressing field is going to help us? Okay, that's great, Jayashree, that's right. Sure, Samir, understand the module 4 assignment second question, is it? Okay. Sure, Samir, we'll just check it during the break. Okay, that's right. So addressing field is the one which is going to give you the direction of a calculation. So in which direction the addressing field is pointing, what the addressing field, whatever you are saying, that determines the direction in which a particular calculation will move on. Okay. So that's what this addressing field is about. Okay. And what is partitioning field? Partitioning field is the one by which the particular operation has to be calculated. So that defines the partitioning field. So separate buckets, each and everything, it makes it into a separate bucket there. So that's what the partitioning field is going to do. So I'm going to take a sample data set with our existing workbooks. So I'll just okay. Let me just open the global superstore data set again. I think it's available for us already, so I'm just opening it from the same data sources. Orders global superstores. Okay. So now, like what we will do, I'm going to take a category field, and within that category, I'm going to take a subcategory. and I'm taking the subcategory field. Okay, so we'll take the sales. Okay, so here now I'm going to apply a table calculation. So for applying a table calculation, I'm just going to right click here and go to big table calculations, and I'm going to say like percentage of total, overall total. So this is what it is. It's going to be the percentage of overall total there. So here it is, it is going to give me the percentage of overall total here. So now I want to determine like what basis this is basically getting computed by. Okay. So I'm just going to go to this compute by, this saying it is table down by default. So what, it doesn't make any difference. If I'm making it a table across and then down, which means it calculates towards your right. So for each and every cell it gives it 100%. If I'm changing it to table across, compute by. So when I'm going to edit this table calculation and see what is happening, when I'm checking on table across, you see there are no partitioning field and no, both are being addressed as the addressing field itself, which means there is no direction given here. So why 100% has come here, friends? Because there is no direction, that is no addressing field selected here, or both are being selected as addressing field, no partitioning field has been selected. So here we have not given any partitioning field, because of which it is just computing the 100% for each and every row there. Are you getting this, friends? So since there is no partitioning field mentioned over here, so in order to mention something as or addressing field, there is no addressing field basically mentioned here. Rather than no partitioning field, at least both have been taken as by default partitioning field. Okay, no issues. So here friends, we understand that partitioning field are something like which partitions your data into separate buckets. And addressing fields is the one which defines the direction you want your calculation to take. Okay, so here if you carefully observe this table across, what it is doing, I have not selected any of the fields, I have not checked anything here. When I am using table across, I have not checked anything here. So what is happening? By default, it is taking both these category and the subcategory items as addressing field. So as partitioning field, I'm sorry. As partitioning field, it has been taken by default. Exactly, Jayashree. So partitioning field and addressing field, so that's what we see here. In a table level calculations, whatever we are seeing, two things are, two types of fields, they rely on two types of fields. The table calculations rely on two types of fields. One would be the partitioning fields and the next one would be the addressing fields. So they will rely on two types of fields here. Okay. So this is where you can know like what is the field that is there. So when I'm selecting table across, you can see both my category and subcategory, both are, so the field which is not checked, what field it is, friends? The field which is not checked, we call them as what field? Is this partitioning field or addressing field? Okay. Okay. Prajakti and others are saying partitioning and few of you are saying it is addressing field. Okay. Now I'm just going to the PPT once again, friends, for your clarification. See, the field by which the values are checked. So if I am checking a value, if I'm putting a tick mark on a value, that field becomes addressing field. If I'm not putting a check mark on a value, that becomes the partitioning field. So here do we have check marks? We don't have check marks. So what these two fields should be? So if I don't have a check mark, it is partitioning field. If I am putting a check mark, it would be the addressing field. So here it is saying partition by both category and subcategory. So that's why it is showing when you are partitioning by category alone, it will compute the percentage for individual panes. I am saying a compute for both furniture and bookcases. So there is only one item, so automatically 100% comes. So the field it is not checked, it is partitioning field. The field which is checked, then we call them as addressing field. Okay. Is this clear, Kalpana, Jayashree, Kanya? Kalpana, are you able to get this? Okay. Manikandan has a question. I thought when we select both category and subcategory, we will get 100% for each row. Is that not true? Okay. Let's see what happens in that way. So here Manikandan has a question. So see here friends, here both the category and subcategory is not checked. What happens when both the category and subcategory is checked? Can you see what is happening? When both my category and subcategory is checked, it is working like table down. This will give me the same result as a table down. So what is happening? It is basically going to compute. So this is going to be defining my direction, right? So direction of my flow of data. So in which direction I need to do this computation? I am just saying you compute in the direction of category wise. And also you compute it based on the subcategory wise. So now what happens when I'm clicking on category on subcategory both, it is basically taking based on the overall total it is bringing out. Yeah. Hope you got this now, Manikandan. How about others, friends? Laugh. Who else? I'm just checking the names. So everyone else got this, friends? Laugh, Salim, Samir, Shantini, Shweta, Prajakti. Everyone got this? Hasini? Yeah. Okay. Okay, friends. Now what we will do, so we will, so this is what is happening, friends. So if you understand this partitioning field and addressing field, understanding a table calculation is very simple. Okay. So this is what the main concept of table partitioning. Okay, I'm just clicking on table down. Can you see? When I'm selecting the specific dimensions, both this and this table down, both are, in this, can you see, both are checked. Both my category, subcategory is checked, and so both are considered as my addressing field. Hence, that would be available as the entire percentage. So overall percentage it is computed. And there is something called table level and pane down. So pane down is what it's going to do. What is checked here on a pane down? Category is taken as my partitioning field, subcategory is taken as my addressing field. So for each and every pane, a computation is being derived out. And what is at the pane level? That is also the same. What happens at the cell level? So cell level also it is happening the same as it is in table across. Both are one and the same here. For this example, both are one and the same. But in different scenarios, each and everything has a different perspective of viewing the data. Similarly, when you can go to specific dimensions, you manually want to mention that, you can do that as well. You would like to see my partitioning field as category and subcategory you will like to see as addressing field. You just check this. Automatically you will be able to get that. Okay, so the manually Kalpana. So for each and everything, for example, each and every action what Tableau is taking, can you see down? So it is very similar to the one what we are doing it manually. So if you are not aware about manually how to do this, so now you know that category will be my partitioning field and subcategory is going to be my addressing field. And addressing field I need to check. So as you know that, you are manually going and checking that. So what happens for people who do not know this concept, they need to rely on this part only, where Tableau itself decides and says that this is going to be my partitioning field. So they have to explore each and every option and see what they wanted. So Tableau by default these options are set. So whenever I'm clicking on this, can you see automatically this is checking that. So Tableau has been programmed in such a way that you do this automatically when it's pane down. Take the second field as addressing field, take the first field as category, as partitioning field. Like that, it has been pre-computed already. So that's why it is showing that. Correct. When we are clicking on the pane down, it automatically selects as the category, subcategory. So unless until we know this manually, we will not be able to understand like how this is working, or we might get a rough idea alone. But however, when you are doing this particularly, at this point of time, this would be, you can have a better control of your data and also better understanding, I would say, rather than control. So when we are selecting the pane down, Tableau is computed already, friends. The algorithms which is returned back in Tableau suggest that, okay, make this as the second field as addressing, first as this. When I'm taking table across, so for each and everything, across means you take it across all rows and all columns. So all rows and all columns will behave like a cell level. So that's why it is showing 100%. Table down would be like across this table down. So down from start until bottom. Take it in a downward direction from start to end. So it computes the overall percentage. And at a table level when you are giving, that is also one and the same. It just considers this alone as an entire table and it computes it downward direction. And what is pane down? Pane down is going to be like, for this pane alone, compute it downward direction. So not across all table, you just compute it for this pane alone, you compute the percentage. That's what this pane down means. And pane also means the same. And cell level is what at each and every cell. This is one cell, computed for one particular cell alone. So that's what this is being said. Is my voice breaking, friends? Is this fine now or still it's breaking? Is this good? Okay. So maybe you just need to check if you're facing any internet issues there from your end. Seems to be like it is fine. So now are you getting it, Kalpana and others who have some questions still? See, whenever this across means across all tables, all columns, rows and columns. Table down means it is just going to compute it overall table level. and pane down is going to be something like for each and every pane. So each and every option has a specific meaning, friends. So whenever we are doing certain things based on certain action, this is how it works. Are you all getting this, friends? Everyone? Please stop me if you are not understanding anything here. Okay. Okay. So this is what the table calculations are about. So now we are going to see some couple of examples for this. So here they have taken the categories, they have basically taken the segments, and based on the segments they are doing year of order date. So as you all know, this icon basically indicates that it's going to be a table calculation going to be applied for this measure. And a table calculation is applied in this way. You can just see that this is how a table calculation would be applied on a segment level. Okay, so we will just see an example visually for this. I would like to have it as a bar tab. I'm just swapping the axis. I'm hiding the show. So what it is saying, percentage of total sales along the subcategory it is computing. So instead of that, what I wanted now was, I just wanted to make it as pane down, pane across. So this is currently being computed across each and every pane. I'm going to do it on table level, table down. What is percentage that is being contributed? So if I'm choosing this, what is happening is, see friends, when I'm choosing this option, compute using the table, let me choose table across. Okay. So this gives me the exact percentage, this is 11%. So which of these items is contributing for overall sales? Highest is 13.50%, which is phones, and 11.94, 11.88, 11.60, and then the smaller categories, 8.91, 7.99, like that. So you can just see that the calculations are differing across each and every pane. What is the calculation that is done there? So you can compute it visually also. So you can just go to compute using category or subcategory, or you can just edit the table calculation and choose specific dimensions, and you can make category as partitioning field and click on OK. So it just computes it by every pane. So in this pane, what is the sales contribution? So 35% has been contributed by chairs and furniture, 36, chairs 36, furniture 35, like that. So similar example, they have just taken it for segment level on a year over year, what is each and every segment that is contributing, so to what percentage they are contributing. So that's what they are showing it over here. Okay, now it's time for you to solve some problems, friends. So can you all please take a open your worksheets and connect to Global Superstore if you are already connected. Can you give me a report on total percentage of sales broken down by categories? I think this example we have already done, so it is just for your understanding once again. Can you all do this, friends? If you have already done, please let me know. Those who haven't done, please do it now. Yeah, that's right, Samir. It is just like the previous example what we did. It's one and the same. Correct. Okay, friends, if you are all done, let's not waste more time. We'll just move on. So is there someone who is left over that you do not know this example? Okay. So Kalpana is done, Manikandan is done. Not sure if the right output though. So this is the output what you should get after that. I'll just show you the output. You please let me know if you are not getting the same output there. So this is the output, sales broken down by the category level. So this is basically going to show you the sum of total for each and every categories, and you can just see that. Okay. So after we are done with this, and so like this is how to create a quick table calculation. And one more thing is this quick table calculations are applied at a table level. That is one thing what we should know. So after we compute that percentage of total, so this is how the percentage of total would look like the final thing. So after we are done with this, the percentage of total should look like something, this numbers for you after you are done. Okay. Now the second thing is, I can't analyze anything from this report. Give me an analysis report on total percentage of sales broken down by categories and subcategories, broken by pane and table. So this is the same example. Now what do you need to do, friends? Broken down by categories and subcategories, broken by pane and table. Are you all getting this question, friends, first? Yeah, this is almost like a same example what we have discussed, friends. So if you are all done, this is how the answer looks for this. So what you need to do is, you just need to take a category and a subcategory level. You need to edit the table calculation and make it pane down. Just make it pane down so that it is getting computed by individual pane level. So this is the same example what we have done. Please let me know if you are all done with that and if you are all able to get that result. No, Jayashree. Actually, here it is possible to compute it, but you cannot have either. You can have two partitioning fields or two addressing fields, but two table calculations. I didn't actually get your question. So, in the same thing, what you would like to do, Jayashree? And very good morning, Lopita. Okay, yeah, not a problem. You can just always catch up as we have the recordings available, so it should not be a problem. So we were looking at the table calculations what we saw yesterday. So here you meant to say computing by more than two fields, in the sense like, so for now it is just category, subcategory. Would you like to have one more field added to this? And you would like to see how to compute that? Is that what your question is? Okay. Okay, table down and pane down at the same time. Okay, so that is not possible. Table down and pane down, that's not possible, Loki. That's not possible, Jayashree. So the only, at a single point of time, we can just choose one of the options. See here, either you can choose compute by using table down, table across, or either one of these options. So we cannot have a hybrid kind of thing because it doesn't make sense, right? So how can you have it? Table down means across the entire table. You need to compute the percentage. But at the same time, you need to compute the percentage for individual panes also. So that actually doesn't make any thing, right? What is the purpose of doing that? So it's not possible for that. Yeah, that's right. Okay, friends. So from now onwards, it's going to be full of calculations for you, and you are going to perform more and more calculations from now on. So I'm going to get you introduced to one of the important concepts in Tableau called level of detail expression, LOD expression. Okay. So what is this LOD expression called? So generally, friends, whenever we are running some complex calculations, when we are running some complex queries which involves many dimensions at the data source level. So, for example, see, I'm having a particular table here. Let me first show you an example, then let's move on to this. Okay. So this LOD expression, if you see, friends, see here is an example for you. Find the amount of sales for each state within each region. So find the amount of sales for each state in each region. So how would you normally do this calculation or this particular thing? Can someone tell me, how would you do that? Okay, we'll calculate the sales at the region and state level. Segmented states in a row and sum of sales in column. Okay. State and region in column, sales in rows. Okay. So, in this example, when we are saying, friends, what is required here is, see, the requirement here is, you need to have the region and state and the sum of sales there. So, irrespective of a region, see here, something different is required here in this question. Find the amount of sales for each state within each region. Okay. So what I'm doing here is, I'm going to take a new sheet. Okay. So we'll see why these calculations are required first. Okay. So now what happens is, friends, I need the sales, I need the region. Within each and every region, I need the state, okay, and I need the sum of sales. So here I require a sum of sales. So here the requirement is slightly different, friends. Find the amount of sales for each state in each region. So for each state in each region. So here amount of sales for each state within each region. Here basically they would like to have the region sales, not the state sales. Sum of sales for each state within each region. Here there is a twist in this question. Sales for each state in each region. So what it means here is, they would like to have the sum of sales for each and every state here which is there within that region. So each and every region there which is there within, which has multiple states within. So what is required here? So the main thing what is required here is, friends, this is what it is. They need the sales computed for each and every region level and not by particular state level. So I might go for a table calculations or anything, whatever I go, I may not be able to get this particular thing. So here one thing what I need to say is, I need to get it for every unique order ID. For example, instead I'm having multiple order IDs. I want to have the region sales for one particular order ID uniquely I wanted to identify. Someone asked me a question sometime before, like how to compute the sum of sales whenever we are having, like for one particular order ID uniquely, how to get the sales. So here in this question, if you are normally computing this, this is how the results would be. However, we do not want this result. The question what the CEO is asking here is, it's slightly different. So in order to perform this, we might need something called level of detail expression. So level of detail is what? I need to get the data to level of detail of with this region, not the level of detail of this state. So first let's understand what this level of detail is, and then we will revisit this problem in quite some time. Okay. So here this level of detail expression is called as a granularity, level of detail of granularity. So they are generally helping us in running complex queries involving many dimensions at the source level, instead of bringing everything, every other thing into the data pane. Okay. So in the same example, assume that I am saying don't bring region into this view. However, I would like to have the sales based on individual region level. Do not bring region into this view. However, you compute the sales based on every region. Is this possible in a normal calculation? I don't have a dimension at all. However, I am asking you bring me the sales based on that dimension. Is this possible? In a normal calculation, what you are doing, can you bring this, friends? If I want to have my sales based on a particular dimension which is not available here, is it possible for me to do that? Okay. So even after bringing the dimension, so for example, I am bringing the dimension region here. So compute my sales based on the overall region level. Now I am saying it is not giving me the sales by the entire region level, right? It is just going to give me by individual state level. I don't want this. I wanted the overall sales of this region. So for which I might have to see, I would like to know for each and every region what is the sales. So what is happening here? So this state I added. Now I'm going to add city. Now what is happening, you see, after I add the city, can you see now? My states are being subdivided into individual cities and sales is being given by individual city level for me. I don't want this, friends. What I wanted is, I wanted the sales based on one particular region. What is my overall sales of this region? So as and when we add more and more dimensions to this view, the data is becoming more and more granular. More and more granular in the sense, so prior to adding the city, I had some amount of aggregation. That is that the state level aggregation I had. So prior to adding the state, I had region level aggregation. Can you see the 66928? I had the region level aggregation. I want this result only. However, after adding the state, my results are becoming diluted. That is, it's becoming more and more granular. See, it's asking me add all numbers. I'm saying yes. And now my sales is getting split over, right? So as and when I'm adding more and more dimensions, the values, what you are seeing, is becoming more granular in nature. Okay. So if we are adding state before a region, that's a very good question, Uncle. So if we are adding a state before this region, now what happens? You see? In Ajman, in Western Asia, this is my sales. In Amman, in Western Asia, this is the sales. Like that, the values are getting split over. So whenever you are making it, adding the dimensions here or there, the values are getting split and they are getting computed in a different way. So there may be scenarios where I don't want these things to happen. irrespective of the view, whatever I am having, I would like to have my things computed based on one particular value alone. So here, this is what this diagram explains to you, friends. So here if you see, they are used in running complex queries involving many dimensions at the data source level instead of bringing all the data to Tableau interface. So you can use the dimensions which are there in the view, which may not be necessarily added to Tableau's view. That is necessarily added as a particular column in Tableau. You need not add that. However, you can bring that dimension in. So that's what they are saying. So what is happening in this diagram? In the initial level, the data is totally aggregated. As and when I add more and more dimensions, my data is becoming more and more granular in nature, and finally it is totally not aggregated and it is more granular in nature. That's what it is saying. So when your data is becoming more and more granular in nature, it will become less aggregated. So you are getting this right, friend. So as and when I am adding more and more dimensions here, state, city, as and when I am adding more and more dimensions to this, it's making my data more granular in nature. Can you see the data becomes more granular? So it has become lesser now. So the state level, the city level, the region level, state level, city level, the data is this. So before which I had at least kind of an aggregation, now even I'm not having that. So this is what is we are going to learn it today, how to make it irrespective of its granularity. Irrespective of its granularity, how to make the data more dynamic. So you will be requiring these calculations to perform some advanced operations, but I'll let you know what those are. Okay, so how to create this calculation? So it's very similar to a normal calculation what you are creating. It's very similar. You just need to right click here, go to create calculated field. So after you do that, there is something called LOD level calculation. So there are LOD level calculations. They are not specifically mentioned here. I think it should be part of aggregate or user level. No, not user level. It's part of table calculations. Okay, that's fine. So there are three levels of aggregations what we can perform, friends. Three levels of calculations are there. I'm going to introduce you to one first. One is going to be called as fixed. And you see, this fixed, what it is going to tell, it needs two expressions. One would be your dimension, and other one is going to be your aggregate expression. So aggregate expression is basically going to be your sales here. So for this example, what I'm saying, so here fixed means what? It will fix my view based on my dimension, whatever I'm mentioning it here. So I'm saying you fix my view based on my region, okay? And you need to enter a colon symbol, and you need to give an aggregate expression for this. Take my sum of sales. So I need to close that open curly brace, a clever bracket I need to open it in order to say it is going to be an LOD expression. And I'm going to say, see what this LOD fixed is doing first, then I'll explain it to you how this is working. So this LOD fixed I have added, I'm going to remove the sum of sales, I'm going to add this LOD fixer. What has happened now, friends? Can anyone tell me what has happened now? Why my value is 66928? So even if I'm having states, if I'm not having states, my value is not going to change. If I'm having my city, not having my city, then my value is not going to change. If I'm having market, it might change. It is not changing as per the market also. So if I'm having my state added, my view is not changing. Add all numbers I'm giving. My view hasn't changed, friends. It is computing my overall sales based on the region. It is adding up all the values for individual states and it is giving me my overall sales here for individual row levels. Yes, as per the calculation fields. Okay. Is my voice breaking, friends? Please let me know. Right. Yeah, Samir, that's right. So, friends, is this breaking now, my voice? Is this clear? Okay. So, Manikandan, please let me know if you are still facing that issue or you please reconnect if you are not able to hear me. So, in order to perform certain operations like this, friends, we might require something called LOD expressions here. Now let's understand what this LOD expression is doing. So this LOD expression, what I have written, it is saying you fix your region and after you fix your region, you compute the sum of sales for that region. First you fix the region and you compute the sum of sales for that region. Which means my view here will be fixed. Irrespective of whatever dimensions I am adding it here, my view is not going to change for this. This will be the same. This is going to be the same. Similarly for Caribbean, if you see, the values is getting repeated. Similarly for Central America, East Asia, Europe, and things, the values are one and the same. Based on that region level, the values are same. Yes. In this view, I'll add you the city as well. You can just let me know. Combination we are getting repeated values, correct? So I'm going to add a city also to this. So let's see. I'm just adding a city to this view. So here I'm just adding a city also. I'm just adding all numbers. And you see now, my view is fixed based on my region. Irrespective of whatever columns you are adding, whatever things you are making, it doesn't make any difference to Tableau. So here we are fixing the view based on the region. Okay, can we get a single value in the sense, single value per region? Single value per city or state? No, I didn't get single value in the sense what you wanted here. Okay, the fixed LOD requires only one dimension, friends. So either you can add more than one dimension also here in this fixed LOD. Now let's see by adding it one more dimension. So I've added region now. Let me add region comma state. So now I have added more than one dimension now, and I need to compute my sum of sales. Now you see. So now it is freezing my view based on region and state level. The values are getting repeated across the state level. So you can make it fixed aggregate value. So how it becomes LOD? Please explain. Yeah, sure, Lokita. It is. So LOD is nothing but it's going to be a level of detail expression, Lokita. Okay. So prior to I was using this LOD expression, I was using directly the sales alone. So when I was having this region, state and city, assume that I just remove the city from this view, and you see my value is constantly changing based on my view. Okay. So here I would like to freeze my view based on certain criteria. So irrespective of that, I am adding city or not to my view, I would like to get the same result. I would like to freeze the views irrespective of whatever fields I am getting over there. I would like to freeze that. So here what I am doing is I am just taking this LOD expression and creating an LOD expression here. So what this LOD expression is doing is basically going to fix my region and state based on my sum of sales. So this is basically going to fix my region and it's going to fix my state and it's going to compute my sum of sales here. So what I am doing here, I am clicking on OK now. Instead of the sales, let me take this LOD fixer. And you see here what has happened? Based on my region and my state level, what is my sales? That alone has come. So this is basically what it is basically going to sum up these three values 1, 2 and 3. These three values and put it there. So when we are having these kind of things, friends, when we are using this fixed LOD, yeah. So how about others? Jayashree, Kalpana, Sagar has joined, Sagar, Hasini, Kanya. Are you all getting this, friends? Prajakti, Shweta. Are you all getting this view? What I am saying? This would be a normal view. This is with LOD. So it makes a difference there. Okay. Okay. So here we will sure, Sagar, not a problem. We were just discussing on this LOD. Yes. So Manikandan is asking which business scenario we are going to use this. Yeah, that's a very valid question, Manikandan. So whenever you are having n number of orders, so there are going to be business scenarios only from now on, friends. So don't worry. The next module number 8 is full of business scenarios only. So I will be showing it to you all of problems. So I told you this module is full of problems only. But for that you need to understand this LOD expressions first. So it's going to be full of problems only. I'm going to give you n number of business scenarios. So for now we can understand that whenever you need to freeze the view of this particular tableau, you can make use of something called LOD expressions. Okay, but we will discuss more business scenarios as we go on. Correct. Yes, that's absolutely right. So whenever this particular example is not that okay, it is just to introduce you to LOD expression, I will take you to the further example. That point of time you will understand exact meaning of this particular LOD, where to use it. Okay. So it's good that you have a question on this, Manikandan. So that's really nice. We will see that in some time. So it is not possible to show LOD expression on row wise like we did for Cognos report, like you want to show the total for each region. Okay, so here this was just an example to show you what this LOD can do at Jayashree. But this may not be an apt example. As we move on, I'll show you better examples. So we can compute the subtotals also here. So the same thing. You may not need a LOD expression here. For example, for computing this, you manually do not need a LOD expression. There is something called totals what you can get. For example, at the worksheet level, there is something called at analysis level, there is something called totals. Show grand total, column grand total, row grand total. Like that, we can have the totals added also, or add all subtotals if I'm giving. Even that will give you this result. So, not mandatorily we require an LOD expression here. You can just add a total directly to this. So, this example is just to introduce you to LOD, friends. We will see more examples. So, you are going to be exhausted with examples and business cases in this module. We will be seeing that more. Okay, so now you understood. So instead of this sum, you can have anything else also. It's not mandatory. It has to be sum only. So here it can be any of the LOD expressions. So you can just edit it. You can just change it to either it is sum, average, anything you can just change. Okay, you can just change it to anything here. Average of sales, sum of sales. You can just compute it for anything. So it's only mandate is you should have an aggregate expression. It can be anything there. So either it can be sum, average, anything, minimum, maximum, count distinct, anything it can be. Okay. So now you understood this LOD expression, how to use it. So there are three things in this LOD expression. So this fixed, what it is doing, it is computing a value using a specified dimension without referencing to any other dimensions in the view. That's what this fixed is going to do. And there is one more thing called include which is there. So instead of this expression, there is something called include. So for example, I am removing the state from this view, friends. Okay. I'm computing my, I'm removing this LOD expression also. Okay. So now I'm going to create one more LOD expression with an include value. So what this include is going to do, I'm going to include my, so this is going to be my sum of sales, which would be my aggregate expression. I'm going to include my state in this. I'm going to include my state in the view and compute my result. So without including the state, this is my total, friends. Based on region and city, this is my total. So by after including my state, So LOD include, basically what it does is, here for example this LOD include, what I'm doing, I'm just saying computed by state alone, right? LOD. For example, I'm removing this region also from this view. Just have it by city alone. Okay. So see now what the LOD include is going to do. I'll edit this. So I'm saying include your region, and include your state and compute your sum of sales. Okay. I'm going to include your region and state and compute my sum of sales there. So here what it is doing here, whenever we are computing it in a normal sum of sales, how this is having, so this expression doesn't require any of the fields there. So whenever you wanted to include certain things from the view which is not there in this view, for example by city alone this is getting computed, right? So for example I'm just saying computed by market, okay. Instead of city, I'm just giving it as market. So now I'm including this LOD include expression. You see now what happens. So it will be including this state and region also along with the market. So this is the normal sales and this is the included sales of that. So LOD include is something like when you wanted to include some dimension which is not there in the view. Based on that, if you would like to compute something, you can make use of include there. We'll see a better example for this, friends. Maybe this example is just confusing us. Don't worry. And there is something called just reverse of this. The syntax of include is, yeah, both are one and the same for now. So that's why I said, told you, Kalpana, like we'll see a better example for this. This one is like one and the same only. So this exclude is just an opposite of this. We'll just understand the syntax alone. Okay. So now don't worry about the examples. We have enough examples. So exclude, what it is going to do. I'm saying you exclude the market from this view. Exclude the market from this view and compute the sum of sales. Okay. It is just an opposite. I just gave it a name as include only. So can you see here? Some of this is the, I should have renamed it as exclude there. So LOD exclude. Okay. I'm just going to click on OK. And you see now, this has excluded my market. This is including my market, this is the sales. This is without my market, what is the sales? This is something very similar to the first one what we saw. Irrespective of everything, it is just bringing out there. So now I am excluding this, I am just adding the sales based on category. So exclude, what it is doing, it has excluded the market and it is computing the sum only based on category. However, this is doing both. This sales is computing based on market and then category. So for now you understand the syntax alone, friends. So that is enough for now. So we will see more examples. So now you got, right, at least the syntax, what it is doing. Okay. So now we will see when to use which LOD expression with some right examples. Okay. So for this example, we already saw this would be like using the sum of sales for each and every region. They would like to have it. So whenever you are using fixed expression, there is something called replication which happens. That's why the values are getting repeated across all the panes, because it is fixing based on the region level. So the same value is getting repeated across. Okay. The next one is calculate the average of sales per state for each subcategory of product. So, calculate the average of sales per state for each individual subcategory of products. What is this? So can someone tell me how to do this one? So calculate the average of sales per state for each subcategory of products. We'll see how to do that. So here you assume that we just have only subcategory here. Okay. So assume that you have only the subcategory items added to this view. So I'm just taking the subcategory alone, and based on the subcategory I'm computing my sum of sales. Okay. So here my question is to use this particular include LOD expression. Calculate the average of sales per state for each subcategory of product. So here my thing is to use the include expression LOD. So in order to use that include LOD expression, I need to create a calculation here. So assume that you don't have a state field here and you do not want to bring your state dimension to this view. That point of time what you would do? So I'm saying include LOD. So I'm saying here sum of sales, I need to write an LOD expression. What is the syntax, friends? It is include my state here and compute my average of sales. Compute my average of sales. So I just created an include LOD expression here. You can just see now how this is working. So this sales is including the state. This sales is without including the state. Now are you able to differentiate from the earlier example? What I showed you was something very specific there. Just because something was there in the view, it has shown you like that itself. So this sales is without including the state level, and this sales is with including the state. Are you all able to get this example, friends? Okay. How about others? So what this include LOD is doing here, friends, it's nothing but it is adding a state level there, including a state here, and computing my average of sales. That's what it is doing. So it is including the state, computing the average of. Okay. So the same thing when we are fixing it. So Lopita has a question, what if we compute the same thing using a fixed LOD? I'll just show you what happens using a fixed LOD. I'm saying fixed based on state and average of sales. So now if you see, the value slightly changes when we are doing it based on a fixed LOD. 139,055 remains the same, and there were some values which just got changed here. So let me take two examples here. I'm just computing the same thing using include, let it be just here. In order to differentiate how it is looking, this is what include has, and I'll make it as fixed also the same. So I'll just edit the fixed LOD and saying fixed based on the state. Fixed based on the sales and compute the average of sales. Fixed based on the state and compute my average of sales. So if I am taking LOD include, LOD fixed, and you see there is slight difference between the values here. So here what is happening, it is including subcategories and state. It along with subcategories, it is including the state and computing my average. Here this fixed is only taking my state and computing my average. So that's why there is a difference in the numbers, what you can see there. Yes. So how it is calculating the values? See here, this is fixing based on the state, LOD fixed. When I am opening this LOD fixed and showing you the computation, it is just computing it based on the state alone. However, here, along with this subcategories, it is including the state and computing me the result. That's why there is a small difference in between this and this. Okay. Now what I will do, the same example I will show it to you with LOD exclude. Okay. So the same example will take, exclude my state or exclude my subcategory, I will say. Exclude my subcategory and compute my average of sales. Exclude my subcategory and compute my average of sales. Now I am going to add LOD exclude also, friends. Can you see now? So it has excluded my subcategory and it just got computed for only one particular item, and the same value it is getting replicated here. So instead of excluding it by subcategory, let me exclude it by let me take state. So something which is there in the view we can exclude it. But if it is getting computed based on something based on the view, so let me say if I am excluding it by state, I don't know if it would make any sense, because this exclude is for something to exclude it from the view there. So whatever item which is there in the view, you need to exclude that. So basically this is the sum without at an individual level it is computing that. And this is by fixing by state. This is by including the state, this is excluding the state, and this is the normal sale. So how about everyone, friends? So at least now you should have got to know how to use these LOD expressions. But I will tell you when to use this LOD expression and which business scenarios we will be seeing that in some time. Don't worry about that. First you understand if you are able to compute this first. So everyone are clear with computing this? You know how to do this now? Now in which scenario, which LOD to use, we will see that in some time. How about other friends, Kalpana, Kanya, Salim, yeah. So at least you got now. Everyone is clear, friends, Shantini, everything. So at least it should be clear for you now how to use and how this LOD expressions are working here. Okay. So now we will see the business scenarios, friends. First, let's understand how to use it. Then we'll move to the business scenario. Okay. So now this is the second problem what we have solved. So here we didn't have the state, so we have to compute it based on each and every subcategory of problems. So this is what it is, the average of sales, and this is how it's looking with computing, including the value. See here, he is saying I don't want region excluded from sales figure calculated for every month. So which LOD expression to use here, friends? He was saying I don't want region excluded from sales figure calculated for every month. Exactly. We need to make use of LOD exclude. Okay. So here what is going to be the columns? You are going to solve this problem, friends. Okay. So just take this. I will not tell you how to compute the LOD expression. What fields I will tell you. You take region, take sum of sales and order date. And you exclude the region from this view. See, I'll just show you the view. You need to exclude, create a LOD expression for this view. Okay. So what we have is we have region in this view. Okay. And we have sum of sales in this view. We have region and sum of sales. Okay. Now there is something called order date. So in a month level, I'm just seeing the data. So instead of year level, I'm just making it month. So on a month level, my data has been seen, friends. So this is my actual view what I got. Okay, from Jan until December, this is what it is showing. Maybe if this view is not appropriate, we'll just change it. Okay, this is fine. So this has been my sales on a month level. So from Jan, this is what it is, and Canada region in the month of October, this is what. So it is giving it by month wise here. Okay. So instead of month, I would prefer doing it by year itself, not to confuse you all more. Okay. So already we have more region. So here I want to exclude the regions. Can you all write an LOD expression wherein I need to exclude my region from this view and compute my sum of sales? Please let me know once you are done. Exactly, Samir. So that is the calculation. So friends, for everyone else, those who have not done this LOD exclude, I'm just showing you the calculation. Please see my screen if you are not getting that. So I'm just excluding my region, and I'm computing my sum of sales. So I'm excluding my region here, and I have just computed my sum of sales from this view. As you can see, this is what it is. This is the syntax for excluding that region and computing the sum of sales. Hope everyone got this thing. Yeah, okay, that's great. So for others who haven't done this, I'm just giving you this example. You can make use of it. So now, what I will do is, the sum of sales that is getting computed, I will take this LOD exclude and drop it next to my sum of sales. So can you see here? This is my sales which has included my region, and this is how my sales. Without including my region, this is how my sales is looking for individual levels. So this is how my sales is looking, friends, on an individual level, and you should get a view something very similar. Yes, we need region and rows. Exactly. The requirement is, Kalpana, here we need region in the rows. However, the computation should not include the region. So here this is with region, considering region as a row, and this is without considering region as a row. Now you understand the difference of this LOD expressions. This is something what we can use it when you wanted to have some fields and you do not want to make use of that field and you need to compute it. You can just see this as an example, and maybe you can have a filter by regions and add a filter by region to see a few regions alone, not everything. So you can just have filters added and just have few regions to compare alone. Central Asia, Europe. Click on apply and OK. Okay, so now you are all comfortable using all three LOD expressions. Now you are done with using of these three LOD expressions. This is how the data would be done there. Okay, so now we will take a short break for 5 minutes, friends. Okay, and we will move on with the business scenarios when to use LOD expressions, and more examples of this on module 8 of our course. We will continue this after a short break of 5 minutes. Let me know if you want to break or we shall continue now. Okay, sure. We'll have a break for 5 minutes, friends. We'll come back in 5 minutes. Okay, Jayashree has a question on are we going to cover the topic called moving calculations and what scenarios we will be using a secondary moving calculation. So the table calculations what we saw now friends, in module 9 we are going to cover how to add secondary table calculations and things, and there we will be seeing about when we are creating something called Pareto chart. We will be using this concept, Jayashree. So we are going to see this, don't worry. In module 9 of this we will be seeing that. Oh. Okay friends, if you are all back, shall we start? I think at least we can complete the case 1 alone today. Not sure if we have time to complete all cases, as we just have 25 minutes more left for us. So, okay friends, I think we can start now. Are everyone ready? Okay. So now coming on to the business scenarios where to apply this. This LOD level calculations are going to be used in various scenarios. We are going to see 6 of those scenarios where it is going to be used. Okay. So we'll take scenario number 1 now. Okay. So the first question is count customers by order. So this question is very simple, looking very simple. So find the number of customers who made Y number of purchases in total. So are you all getting this question, friends? Find the number of customers who have made Y number of purchases in total. That is going to be my first question. So my first question is here, find the number of customers who made number of purchases in total. So what has happened here? So I need to have a view first. First let me explain you this scenario. So there is number of customers, friends. So customer name is there. And who has made number of purchases. See, I want it in a form of a graph here. Okay. So these are my number of customers, and I would like to know the number of purchases. So this customer, I am getting the number of sales. So maybe I would like to have the quantity in which he purchased. So we have the customer name here, and what other fields we require? Okay, so we might require the order IDs here. Okay, I don't want the sum of sales. I want the order ID of the customers who has made the purchase. So this is my scenario there. So what is that I am having? So I need to compute this customer have made how many orders. So from this view I am able to see it is 1. So this customer, Vivian Mathis, have made how many orders? Likewise friends, I would like to have the number of orders and number of customers who have made that orders. I would like to have a count. Yes, definitely I will use a count of orders. So here friends, as Manikandan is saying, I am just going to use count of orders. I am going to create a calculated field. There is something called count distinct of order ID. I am just giving an order ID. I am clicking on OK. So this count of order, I am just having it added here to our view. Now how is my view looking, friends? See, it is showing for each and every order ID, one customer is there. Correct? So this is one customer and this is the other next order ID, this is the other customer. I would like to know what is the total count made by this customer alone. I want that alone to be displayed. I wanted to know how many orders did this person alone make. If I am using count distinct of orders, am I able to get that details? Am I getting that? See, everyone has made one order, so everything is coming as one. If I am using count, so instead of count distinct, if you want me to make use of count, I can use count also. I am clicking on OK. So this, for example, this person has made 4 orders. This has made 2. This has made 1. So now what? If I want a graph, I don't want this to be grouped based on my order ID. I would like to have it based on my customer name. For each and every customer, I would like to know what is the order that has been made. So this 2 plus 2 plus 2 plus 1 plus 4 plus 2 plus 1. I would like to have a sum of all these put together in a single view. Now are you getting the actual thing, what we do not have in our calculation? Why we need to use this LOD expression here? Can we get this result, can we get the desired result without using LOD expression? Can we imagine to get that? So here I need my number of orders placed by individual customers only, friends. So how to get that? Okay. Here, what if we remove order ID from our sheet, customer ID or name, LOD exclude the sum of sales? Yeah, exactly. So here, friends, I am explaining you a scenario when you need to use this LOD expression. So if I am removing this order ID from here, what will happen? This will be showing me by one customer what is the order. Now you are getting right. If I am removing the order ID, I am getting that count. For individual customer, I am getting a count of order ID. So here when I am making this as to be a count distinct, so I would like to have a distinct order placed by each and every customer. This is my overall order. I am just getting that now. If I want to get distinct orders, what I need to do? So here I can change it from normal count to count distinct. So after I make it to count distinct, you see what is the result. Now, these are the unique number of orders made by individual customers. 25 unique number of orders, what was placed by this customer. So these are my customers list, and these are the orders what they have placed individually. So here what we need to use is, I need the number of orders and number of purchases in total. So what he needs the number of customers who made number of purchases. So this is one customer who has made like 23 purchases, one customer 24, one customer like this. But here, why we need to use an LOD expression? So here we are going to fix the customer names and the number of orders made by these individual customers. And we are going to do it by measure count distinct here. See, this is what my view is required. 62 customers. So I don't want it by my customer name. If you get this is the output what I need, friends. This is the output what I need. I need the total number of customers. So in a scenario, I would like to see in what scenarios like maximum number of customers are purchased. So see here 30 customers are made 62 purchases. So 30 customers have made 62 purchases here. So how many customers made how many purchases? So how to get this view, friends? So here I am getting this view, this is fine. I am saying this customer made 24 purchases. So I wanted to know the count, like how many customers made maximum number of purchases. Are you getting the question here? Are you all getting the question what is asked? The question what our CEO wants here is, he wants to know total number of customers who made total number of purchases. Like 10 customers made 20 purchases. Like that he wants the data. So even here if I am removing the order ID from the view, I will be getting the individual customer names only, but how to make my customer name distinct. So you can tell me one more option that I can make a count distinct of customer name. But how to make this customer name fixed? So I need something like 30 customers made this many purchases. I don't want it by their individual names. So in order to solve this problem, friends, so are you all getting this question first, friends? What is required here? Okay. So here now what I am going to do is I am going to create an LOD expression. So what I am going to do in this LOD expression is I am going to fix my customer names, and I am going to find count distinct of my order ID. So instead of the count of this order ID, I'm going to compute count distinct of my order ID. Okay. Now what happens, you see the difference. This is the count of order IDs, this is the count distinct of order IDs. This is one and the same for now. Okay. Now what I'm going to do is, now I have computed the fixed sum. So this will work like very similar to my count distinct only till now. Okay. So after I'm done with this calculation, what I'm going to do is, so I need to group the what is required for me. I have fixed my customer name and count distinct of order ID I have created. Okay. Order by customer I have created a field. So this order by customer. So this is going to be the field. I'll just rename this as order by customer. I'll rename it as order by customer. Okay, I'll just create it in a new sheet, friends. Here it might confuse us. So I'm just removing it from this view. Okay. So here, this is going to give me the count of orders, order by customer. It's going to give me number of orders made. And what else I need? I need the customer name here. So customer name field, I'm just going to take it here. So these are the number of orders by customer is 37, like that I'm getting a count here. Okay. I'm just getting this. Now what I need to do? I have created this. I have created my sum of order by customer. I just got it. Count of my customers also. So I'm just converting order by customer to a dimension and dragging it to a dimension shelf first. Okay. So why I'm doing that, friends? Why I'm dragging it as a dimension? Because it's no more a measure it is, because it's going to be doing a count this thing there. So this order by customer, I'm going to right click here and convert it to a dimension. So as soon as I convert it to a dimension, you can just see that I just pulled it into a dimension shelf. And what I'm doing, I'm just going to this customer name. So here, instead of the customer name, I'm making it as count distinct of my customer names. Okay. After I'm making it as count distinct of my customer names, I'm just changing the value to discrete. And sum of order by customer, I'm changing it to discrete as well. Okay. So what I'm doing, so after I change this view, I just made this converting order by customer to a dimension. I have changed it to a dimension. I'm going to the measure. I'm changing the count distinct. Instead of the customer name, I'm just changing it to count distinct. So count distinct would be my this, and order by customer would be my continuous field here. So it is just the reverse. So this is going to be my continuous field, and sum of order by customer is going to be my discrete items. So this is for now giving my data. So this is saying like distinct count of customers, 796.25728 customers made. So 278 orders, 25,728 orders have been made by these many customers there. So how to get something like this, the same view as we saw it over there. So this order by customer, I just need to convert it into string values. So this sum of order by customers, whatever we are seeing it over here, friends, we just need to make it look in a similar fashion as it is. So after moving it there, we just dragged it to the dimension shelf and we made this as order by customer, looking like this. And it is basically computing sum for us by default. So why are we dragging this particular field to the sum there, friends? So it is basically computing my sum there. So I don't want this aggregation to happen there. So I'm just making this sum as count, or I'm just making it as, I don't want this aggregation to happen for this. So I'm just going to change the order by customer. So I'll just remove it from this view. I'm just going to change it after I'm dragging it as dimension. I'll just drag it now. Let's see what happens. So when this is not a measure, it should not aggregate the value. Yeah. Now can you see? These are the number of orders made. So how many orders? 30 orders are being made by 62 unique customers. So this is what I wanted here, friends. I wanted to know how many customers made how many orders. Here, so this is the view what we are finally deriving it out here. Okay. So one question, how many of you understood this now? Or how many of you would like to have it repeated once again? Sure. Sure, friends. I'm just repeating it once again. Okay. So this was our initial view, what we got, friends. Yeah, it was confusing, right? Yeah, don't worry. I'll just show it again. Okay. So this was the initial thing what we did. We just took the customer name and I just took the order ID, count of order IDs. So it is one customer name, how many orders they have placed and these things. However, I would like to have something different here in this calculation. So what I did was here, friends, I just made it as count distinct. So this was my initial view, what I had after seeing the question. So what I wanted is something like this I wanted. So how many customers made how many orders? So I'm just converting this value as discrete. Let's see what. See, this is what the view what I got. So this is the view what I got without using an LOD expression here. So count distinct of customer name. So I'm just dropping it here. So I should have something like this. Customer name, count distinct. Do we have a calculation created? Okay. See, customer name value is there, friends. So I'm going to create a calculation on top of the customer name. See, I'm just right clicking here, create a calculated field. So I'm making it as calculation 1. So I'll make it as count distinct of customer name. Okay, I'm just applying this calculation. Call calculation 1. I'm just dragging this calculation 1, dropping it over here. Okay, this calculation I'm unable to do that because it's taking the unique count, it's not allowing me to do it as discrete. Okay, so in a normal scenarios we cannot do this, friends. So that's what I'm trying to explain it to you through this. So we'll see how to do this with an LOD expression. Okay, so what we did, we need the distinct count of customers with the distinct count of orders there. Okay, so for that what we did, we just created an LOD expression. So this is the LOD expression what we created. So this fixed of customer name. So I'm just recreating one more expression in a similar way. So I wanted the distinct count of my customer names first. So for that what I'm doing, I'm just going to this customer name field, right clicking here, I'm creating a calculation. So here I'm going to create this calculation, friends, distinct customer name. So in this, what I'm doing, I'm taking my customer name and I'm taking the count of those customer IDs, count of distinct of customer IDs. So what it does, it fixes my customer name and gives me the order IDs. Okay, it gives me the order IDs for individual customers. So distinct customer name count, I have created it here. So I need to make it as a dimension prior to I just add it there, because what happens is if I'm having it as distinct, it will aggregate my value. I don't want my value to be aggregated. So first I'm converting it as dimension. Correct. So the reason is, Lopita, what happens is, see the same field when I'm having it as a measure, okay. Assume that I'm having it as a measure itself, right? See, when I'm just dragging this value to my columns, what it is doing, it is making my sum, right? I don't want my aggregation to be done there. So how to avoid that? So in order to avoid that, Lopita, what I'm doing is, I'm just removing it from the measure and dropping it into my dimension. So why I need to drop it to my dimension? The main reason is because I need the distinct count of my customers based on the number of orders they have placed. So if I'm not doing that, it will aggregate my sum by default. I have no other option to change it. That's why I'm converting first into a dimension. Okay. So after I'm converting it to dimensions, I'm dragging this field, dropping it over here. Yeah. So now my data is not getting aggregated. It is just simple. Okay. And now what I'm doing, I'm taking my customer name. So what I need, my requirement is I need the number of customers, and also I need, based on the customer name, I would like to have the count of the orders there. How many customers made how many orders. So this customer name, I'm just going to measure value here and I'm changing it to count distinct. And you see now, as soon as I did that, I'm getting my values. So 30 customers have made 62, 62 customers have made 30 orders. 52 customers, 31 customers have made 52 orders. 33 customers have made 55 orders. So, similarly, I can create a tooltip here and I can just say these many customers, distinct customers, 30 customers made these many. Okay, so this has to be my first field. Made these many number of orders. Okay, So I'm just converting this as a tooltip, friend. So it's saying 62 customers made 30 orders, 53 made 32 orders. I just may change the tooltip there. Yes. So for this distinct customer field, the LOD calculation you are asking, distinct customer name. So this is the calculation what I use for distinct customer name field. Okay. So this is the calculation what I created for distinct customer names. So I'm just sending it to you all for your reference. So friends, this was an introduction for you all to LOD level of calculation. So there are more complex examples what we are going to solve in the class. Yeah, okay. So you didn't get the desired result. Okay, no problem, Monica. So friends, this was an introduction to this LOD calculations to you there. So these LOD calculations are really useful in scenarios where you cannot use the existing calculations and stuff. When you wanted to perform something complex, this LOD is the one-stop solution for you. This will help you out in doing that. So the same thing we tried normally, we were not able to get the results, right? Like this. We could not get the results. So in these scenarios, we might have to make use of something called level of detail expression. And this is what it is. What we need to use. So tomorrow we will see more advanced things, friends. So before that, what I want you all to do is, you please have a look at these. What you clarify yourself, you do a practice with you, and you please go through this link what I'm saying before coming to tomorrow's class. Okay, this should be good. Overview of level of detail expressions. So I would like you all to please go through this, friends, and let me know your input after you are going through this content. Okay, so I want you all to please go through this LOD expression. This has the various things what we have, what we saw today, and what are the things, limitations, what are the stuffs what we have for LOD expressions. Everything is given here. So there is something called table scope level of detail expressions. You also see that, and include, exclude. You just see them. Okay. And after seeing this, you come tomorrow for the class. See, these are some of the use cases. One is cohort analysis, and totals, averages across segments, aggregates of aggregates, binning aggregates. So these are something real-time scenarios. We'll see an example for each of these. Okay, so friends, we'll have classes until this week fully, and maybe next week we'll have 2 or 3 classes max. So that's what I'm estimating. I think within that we should be done. So we have tomorrow, the day after, and then 2 or 3 classes. So maximum 5 sessions we'll have max here. Okay. So friends, did you all get the concept of this LOD? We are going to see more business scenarios tomorrow, so I don't want to load everything today itself for you, because I know this is a difficult concept to understand. So it will take some time for you to get it registered, friends. So please don't worry. So when this LOD expression, when I had to learn, I had to read it 2 times, 3 times. Then finally I got to know on this LOD expression. So it will take some time for you, so don't get worried just because of that. You don't need to worry on that. Okay. Okay, friends. So I'm just stopping the class with today with this topic. So we'll call it a day, and you all go through this link and come tomorrow. We're going to solve even more complex business problems tomorrow. Okay, using LOD expressions, we are going to solve them. Okay, friends. See you all tomorrow. Thank you, Hasini, Jayashri, Kalpana, Lam, Lopita, Prajakti, Sagar, Salim, Shantini, and Shweta. Thank you, everyone. You all have a great day there. See you all. Please go through the link tomorrow and come, or else everything is going to be bouncers when we are working on tomorrow with the same topic. Okay? Okay. See you all. Bye-bye.